So today we're going to talk about the importance of language in math testing questions. There's a story that my father tells about Dr. Moore and his alarm clock not going off. He says he came in one day late and said, "I'm sorry I'm late, my alarm clock didn't go off." And then he thought about the accuracy of that statement and said, "Well, okay, I'm not sure that my alarm clock didn't go off, but I didn't hear it go off." Then he thought about that, and he said, "You know, it's possible that I heard it and fell back asleep and forgot that I heard it." And finally, Dr. Moore's colleague said, "It's okay that you're late. You do not have to cover every possible reason that you're late." So accuracy was very, very, very important to Dr. Moore. It was also very important to Dr. Wall, who said in the preface to this wonderful, wonderful book, "In this book, I have tried to say exactly what I mean according to my best understanding of the English language. There are fine shades of meaning in the language used. The little words are especially important. For example, if a man says, 'I have a son,' it is not to be assumed that he does not have two sons. Thus, in this book, a set which contains 10 objects contains one object and may contain 20 objects." Now, some of you received my little advertisement for today's talk, which was hopes that anyone would come, since you have John Neuberger. I shouldn't have said that. Don't block the door, Randy, so people don't run out the room. John Neuberger is speaking right now on calculus, and I'll close my eyes if you need to leave. My feelings will be hurt. So I made this little advertisement, and please tell me your answer that you got to number one. Okay, a lot of people thought there was one huge tart. Yes, that's what I thought too. I thought you should make one huge tart, and your huge tart should have 72 raspberries and 72 blueberries. My guess as to what they meant was that they wanted you to make 9 tarts, and each of them had 8 raspberries and 12 blueberries, and that way you would use all 72 raspberries and all 108 blueberries, but I really don't know. But the plot thickens. This was the question. This is the actual textbook. Well, here's the question, and they made it a little trickier. Look, they have a picture that shows blueberries and raspberries in the same tart. So that's kind of a clue or a trick. But this was a review copy of the book. Here's the final version of the book. Somebody told them there's something wrong here. Somebody told them that there's something wrong here. So here's the new version. Okay, same picture. There's a little clue here. It says, find the GCF. I hate it when they do that and they don't spell it out for you, like you're supposed to know what that means. But anyway, Jose is making fruit-filled tart shells for a party. He has 72 raspberries and 108 blueberries. The tarts will each have the same number of berries. Raspberries and blueberries will not be in the same tart. Okay, that's new information. Never mind the picture. If he puts the greatest possible number of fruits in each tart, how many tarts can he make? So unlike Moore method, I am looking for speed today. So instead of going home and thinking over it or running out of the room so you don't hear the answer, I would ask you, against Moore method, to please quickly shout out your answers. I see several people saying 2 tarts, and that's what I thought too. I thought you should make 2 huge tarts, and this time you'll have leftover blueberries. The answer in the back of the book was 5. They wanted the greatest common factor of 72 and 108, which is 36. They wanted you to put, I'll show you the question again, sorry. They wanted you to put 36 raspberries in each of 2 tarts, using 72 raspberries, 36 blueberries in each of 3 tarts, using 108 blueberries, and then you'd make 5 tarts and would have no leftovers. They didn't say what they meant, did they? So the student who gets the correct answer 2 gets triple extra credit because the book was wrong. So this is actually a great learning experience because the textbook is wrong. And you can tell your students they are so much smarter than those authors. But the entire rest of this talk will be about terrible, terrible things that are done to students, which is to put assessment questions, test questions, high-stakes test questions, questions that the teacher has no control over, to the students. So we will discuss the importance of correctness and precision, why instructors should take care, use careful wording and inquiries presented to learners, and those who produce these tests for students should be error-free and exact, but unfortunately, they are not. This is a 5th grade test question. What answer did you guys get to that one? Kind of bothered you, didn't it? Bothered me too. My nephew said, well, they're the same according to the figure, but I know that they're not the same. I know which one's bigger, and I can tell you. You felt that way too, didn't you? So, but that's not a choice. It's A or B. You have to bubble. You can't explain. You can't write a paragraph. And you get no extra credit for being smarter than the author. In fact, you lose. Your teacher may lose. She may lose her job because your test scores were low. Your school may lose. You won't make AYP. Your school may be closed because you didn't pick more or less. This is very high stakes. There are a lot of different categories of mistakes. Sometimes the mistake is in the misuse of terms. What are the roots of the function x squared plus 11x plus 24 equals f of x? Are they negative 8 comma 0? There's not an and, there's not an or, there's not a comma, so there's just a little space there. Negative 3 comma 0. And here's your other choices. You have to color in A, B, C, or D on your Scantron. Well, as I told my department head, roots by definition are x values for which y equals 0. They are not ordered pairs. And the correction that I suggested to my department, this one we did have the test in advance, although it was provided within hundreds of copies already copied for us, given to us by the district at their expense. So I had to change by pen on every one. I suggested we change roots to x-intercepts. Of course, I was the only one in the department who cared enough to make that correction. Another common mistake is things are ambiguous or unclear. This is from a high-stakes benchmark test. The regular admission price for one person to an amusement park is a $5 entry fee plus 50 cents per ride. Which quantity represents the slope? Your choices are total cost, entry fee, cost per ride, or time at park. Those are your choices. Well, as everyone knows, in 9th grade, you are supposed to pick the one that has a rate in it. But I saw 2 rates. Did you see 2 rates? This is how I fixed it, and this required actually a great deal of glue. I had to individually glue the wording over all the several hundred copies of the test I was given. The regular admission price for one person to an amusement park is a $5 entry fee plus 50 cents per ride. Scratched out which quantity represents the slope. In a function where x is the number of rides and y is the total cost for one person, which quantity represents the slope? By the way, if I've made mistakes, please tell me later. I probably have, and I would like to be berated on that point. As a Mahavier, I think I'm always right, but occasionally I'm not. Here's, yes, sir. Yes, sir. That is an excellent point. A point that most public school teachers would not get, and the person writing this test did not get. Another common mistake is that there's no right answer. Now, this is one of my pet peeves, and it's not as easy a one as the others. Simplify x squared plus 2x minus 8 over x squared minus 2x minus 24, and you have 4 choices. This is a really fun problem because you get to factor, and you get to say, whee! I don't use the word cancel, but when you divide and reduce. Yes, the gentleman did teach me how to make it bigger. Let's try that, bigger. Thank you. Okay. But there is something seriously wrong with these 4 choices. Thank you for nodding. I've fought this battle for over 10 years, and I've lost at every school, in every department. Here is my complaint. Restrictions were left off. The expression does not equal any of the answer choices. It equals such and such with the restriction that x cannot equal -4. If you're not sure about this, graph y equals x minus 2 over x minus 6. -4 is in its domain, but -4 is not in the domain of the other. Comment, NCTM recommends against using the term simplify. And then I changed it to, oh, I'm sorry, you can't read my comment. The question should read, reduce the expression, and the answer should read such and such when x is not equal to -4. And this isn't beyond children's ability. I've taught 6th graders to say x is not equal. It's kind of fun to say what it can't be. Another common mistake is that it's rounded, but it didn't say so. I've stamped my feet at this one and lost. Use the quadratic formula to solve 3x squared minus 7x minus 5 equals 0. Well, there's your choices. Pick one. I don't like the comma. It should say or. And all the answer choices are wrong. The correct solutions are irrational numbers, but only rational numbers are given. And nowhere is it indicated that they are approximate. You should replace the equal with approximately in all answer choices. In my opinion, this is a serious error in modeling to present students with a multiple choice answer like this. This puts our student in the position of choosing from answers, none of which are correct. We should demand exactness from our math students, not accepting x equals when it's not equal. It's a terrible example when we give multiple choice examples like this. I asked Kathy Seeley, she was the president at the time of NCTM, her opinion, and she agreed with me. So I got a big name on board with me. But nobody in my department agreed. They said, they'll know which one to pick. And then there's funny questions where it's not what you meant. Leslie has 2 cups containing different, this is a really old Elmo and it's really fuzzy, different colored paper clips. The first cup contains 7 pink paper clips and 3 blue paper clips. The second cup contains 3 black paper clips, 1 red paper clip, and 6 orange paper clips. Obviously, this is a real life setting, isn't it? What is the probability that Leslie will randomly select a blue paper clip from the first cup and then randomly select an orange paper clip from the second cup? Did you notice that they didn't say what they meant? They didn't say if Leslie randomly selects a paper clip, what is the probability that she gets first a blue one and so on? What is the probability that Leslie will randomly select a blue paper? I think it's very low. I doubt that Leslie would do that. Don't you? Have you ever seen Leslie have a desire to randomly select paper clips? So they didn't say what they meant. All right, you seem to be doing very well with this, so I'm going to give you some exercises. I want you to think about what are the consequences for students of errors in questioning. I'm already giving you some clues. I also want you to think about what are the implications in instruction of such errors in assessment questions. And I'm going to invite you to comment on the questions. Tell me what, if anything, is wrong with them, and how would you fix it? Sam spent $24.75 to buy 12 flowers for his mother. The flower arrangement contained roses and daisies. Roses, R, cost $2.50 each, and the daisies, D, cost $1.25 each. Which of the following systems could be used to find the number of roses and daisies that Sam bought for his mother? I was hoping to hear an answer faster, but let me ask you, in your experience teaching college, do you frequently have a variable R representing a flower? Thank you. Number, that's a math word. Yes, yes. And this was hard to fix. I had to cross out the R and the D and add the word S, the letter S after numbers, and insert R after roses in the last. Find the number of roses, comma, R, and the number of daisies, comma, D, that he bought. Variables don't represent flowers. Okay, this is an easier one. Please don't be shy. Call out your answer. Find the vertex of the parabola. X squared plus 4x equals 0. That's not a parabola? Parabolas have x squared in them. Try again. You have an equation there, yes. So how would you fix it? Very good. You could mark out the 0 and put a y. Would there be anything wrong with it then? Okay, so there you go. That was an easy one. Okay. Which expression can be used to find the values of p in the table below? This is an 8th grade question. Here's your table. 1, 2, 3, 4, 5, 6. Here's p. 5, 8, 11, 14, question mark, question mark. And your choices are 3n, 5n, n plus 4, and 3n plus 2. Is there anything wrong with that? And so the fix would be easy, right? How would you fix it? Is that what you were saying, or did I misunderstand? You write the n in there. There you go. Okay, that would work. So the first reason why these examples are just terrible is they're modeling sloppiness. That is the worst thing we can do. Modeling sloppiness. The students will learn to be sloppy. If you have, in fact, taught them vocabulary and the importance of vocabulary, you have now untaught it. X squared equals 0 is a parabola. You've now untaught your vocabulary. Let's compare this to another bad teaching practice, that of algorithms. Have you had students to take this question, factor x squared minus 9, which is a really good, fun question. You can check it by distributing, right? Make sure you're right, prove that you're right. You can prove you're right. And get this answer. That's the answer, right? X equals 3 or negative 3. Well, you might not get that whole answer right. So, did I say solve? Did you see an equation? Or is vocabulary not important in this course? Here's another reason that this is bad. You will lose your sharpest students. Thank you for nodding. I thought this was kind of a harder point to make. You may be thinking, okay, well, your stupid students are in really big trouble, right? They're not going to learn. And you don't even know that they're not learning. All you know is they got it wrong. But you're going to lose your smart students, too, because those smartest students are going to lose interest. They're going to think, well, this is a bunch of baloney. Yet I thought I understood the definition of variable, and then you tell me R equals roses. And when they're 9 years old, they can't really verbalize that either, can they? They just learn that the questions don't really make sense. And working them is just a matter of figuring out what the teacher is looking for, not something provable. They're confused. They're annoyed. It doesn't make sense. They're turned off. We destroy their interest, and we destroy it very early. So this is a speed round. Can you tell me very quickly what is wrong with this? And tell me if I'm in a disaster with the there. What is the standard shape of a quadratic equation? Right, it usually has an X shape and is a little squared, right? Okay, okay. All right, good, an equation. It doesn't have shape. All right. Find the vertex for the following quadratic. Y equals such and such. 4 choices. Thank you. Quadratic is an adjective, isn't it, Dan? Good job. You get the bonus point for that one, Dan. Furthermore, a function or equation doesn't actually have a vertex. I think I've made this mistake, though. I think I've said, might have corrected it. Find a vertex for the following quadratic function. That's not right either. I should have said the graph of this function. The graph has a vertex. Find the vertex of the parabola whose equation is. Okay? This is another 5th grade question which annoyed my little nephew. Susie planted a tree that grew so many inches in the first year, so many inches in the second, so many inches in the third, and so many inches in the fourth. During this time, the tree was also pruned so many inches. How much taller was the tree after the 4th year? Correct. Taller than when? Than the 3rd year? Than when you started? I don't know how tall it was when it started. Thank you. After the 4th year, yes, when did you measure? During this time. Thank you. Here's a graph. Ted created a graph to show the percentage of time he spends on different activities during a school day. Sleeping, 35%, and so on. Ted concluded from the graph that he spends about 48 hours at school and doing homework during a 5-day school week. Really? Didn't he actually make the graph by counting the hours? The next thing that is wrong with giving assessment questions like this is its implications. The implication is that there was a lack of definitions, that there was poor teaching, in fact, poor knowledge of content, and poor knowledge of content at a very high level at your district or your state. And my possibly most controversial, I think that another implication is that the teacher or somebody is being unethical and uncaring. Would you present your students with this? Wouldn't that be a violation of trust? Is that fair to give garbage to your students? I've gone to a great deal of trouble to try to avoid giving garbage to my students. One time when I had no choice but to give them the test, I made this whole bonus thing. Don't try to do. The questions have errors. No tratan de hacer hoy. Choose this answer, A. What is the error? And then you get to fill in the bonus. The correct answer is not here. Fill in the bonus. I had no choice but to give it to them. Other times I spent my entire spring break correcting answer keys that my district paid a lot of money for. Oh, okay. I kind of put my questions in the middle. So, all right. So my conclusion is, how important is our assessment questions in inquiry-based learning? This is a rhetorical question. You don't need to answer this one because inquiry-based learning starts with the word inquiry, which means question. I think there's a great need for care, and I hope I've made this point. How does exposing students to poorly worded questions affect their learning? It models sloppiness. It teaches them to be sloppy. It unteaches vocabulary. It loses the sharp students who might have grown in mathematics. I make a plea for more care in the wording of questions written by Pearson and those that we pay gabillions of dollars to create our statewide assessments and the assessments that our districts pay big bucks for. There is a great need for care in the wording of questions, and questions like these are a great enemy of more method and inquiry-based learning. I have a lot more classwork for you guys, but Randy helpfully points out that I am about overtime. So, thank you.
Hi, Katie Wanick, University of Nebraska at Omaha. In Nebraska, all of our standardized tests are through a computer program, and they're randomized questions, so you don't even know what your students are going to get, and you can't see it. They don't let you see them. So do you have any ideas on how to make up for how bad these are? Like, are there people to talk to, and what do you suggest?
Thank you, Katie. I think this is a question for our legislators. You don't know what's in those tests, but somebody paid money for those tests, and you as a teacher should be able to look at that darn test, and if it's wrong, you should be able to say so. I think the only reasonable preparation you can give is to show your students some bad questions in advance and to have them discuss why they're bad. If the students come to you after the test and discuss it, and you close your door so you don't lose your teaching certificate for discussing the test, because you signed a document that you would not discuss the test, look at the test, become aware of the questions on the test, but you close your door and then say, okay, what did that question say? Are you sure? And if 5 other children say, yes, miss, that's what it said, then you can say, well, let's talk about that, why that was a really bad question. And here, you get a 300 on the next quiz because you pointed that out.
Thank you for this talk. I think these are very important points.
Thank you. It's been my pet peeve for over 10 years.
One of my, my Calculus 1 students don't know what equals means. Every semester, many students will put an equal sign between expressions which are not equal, such as x squared equals 2x. And I'll circle the equal sign and write not equal many times. Another instance, when my daughter was in the 8th grade, my wife and I were homeschooling her. And she took a correspondence course from Texas Tech University in algebra, beginning algebra. And we spent much of each time together just trying to correct the mistakes in the text. Daily, many errors. My favorite error of all time is the place where inverse functions was defined. F and G are inverse functions, means that f of g of x equals g of f of x equals x. So ponder that, where one function is the exponential function and one is the log function, and you'll see this is very wrong.
Nothing was said about the domain.
No.
Yes. I think it was Howard Cook who said, when someone said, well, you're right, equals should only be used between 2 numbers, and Howard Cook says, between 1 number.
Hi, Dana Olenoff, Widener University. You had said that you were the only teacher in your district or in your building or something that seemed bothered by this. And so my question is, how do you get other teachers to buy in?
You know what, I have the Humane Society view of this, and it's a harsh one. At the Humane Society, there comes a point where you just give up on finding homes for all those litters of puppies and kittens and you euthanize them, and you start a spay-neuter program. I think it is a lost cause for the great majority of current teachers. I have taught in a number of different schools and school systems, and it's a very bad situation out there. I think we have to work on the pre-service. That's a harsh view, but I give up.
Sharon Butz, semi-retired. In any class that I taught, which included university classes, I also taught 7th and 8th grade. I start out by talking, by explaining that mathematics is a language with which we communicate in this language. And I say several other things, but back to the equal sign, I tell them that the equal sign is a sacred symbol in mathematics, and you'd better at least believe that what you put on the left is precisely and exactly equal to what you put on the right. And so I start the first day of class, any class, emphasizing that, and throughout the class, we work on precision and accuracy.
You're right. If all they learn is what equals means at 5th grade through 10th grade, that would be wonderful. And definitions are to school teaching as axioms are to college teaching. You are completely right, and that is the basis of IBO.